Hello guys, welcome back to our channel Planet for Tech. I hope you all are doing great and learning lots by watching all the continuous episode of the series Python Beginner to Master. So guys, till now we have completed 13th episode of this series and today in the 14th episode I am going to describe you the next part of the data structure in Python. So this is a user defined data structure. So we have seen like there are two category of data structure, built-in data structure and user-defined data structure. So under the built-in data structure comes tuple, list, sets and dictionary. But there are the next category of data structure that is user-defined data structure. So in this we can further classify this data structure into two types. So these are the linear and non-linear. So this comes basically queue, stack, and graph, tree, so linked list. So these all comes in the user-defined data structure. So today we are going to see this user-defined data structure in a depth way. So stay till last and just see what amazing thing we are going to understand today. So let's start. So as I have told you, like these user-defined data structures are built on the top of existing built-in data structure. So you can see here, these data structures are the ones built using the built-in data structure and have their own properties. Definitely they are having their own properties. That is why it is in categorized in the second other category, that is user-defined data structure. So based on their situation and you can see here we have we can categorize this data structure in two ways. One is the linear data structure, another is the another is the non-linear data structure. So this data structure I have marked here in a different color. So the color showing red is a linear data structure and the black color showing here it is non-linear data structure. What means this linear data structure and the non-linear data structure? This is nothing but the way of organization the data. If the data are organized in a linear sequence manner, so it is called as linear data structure. If it is hierarchical, means there are some hierarchy or structure, so that is called as non-linear data structure. So you can see here array, which is going to be referred as matrix in the Python. Mostly we will use the matrix. So there we are going to use the array. And another one is the stack and queue and linked list and hash maps. So these five, the first five are the linear data structure, and the six and seven trees and graphs. So these are the non-linear data structures. So all these seven data structures are user-defined data structures, which works on the top of the built-in data structure. Now let's see each one. So guys, you can see here. So these arrays in the Python, what the arrays are. So these are similar to the list. So what we have already seen in the built-in data type. So list are what? List are mutable data structure. It means we can change its value, and list we can access its element by their indexes. So the similar kind array is also having similarity like the list, but there is a one difference. That only difference is list can have the data of different data type, but the array always take the homogeneous data type. It means it always take the same kind of data. Let's suppose here I have taken one example of EMP array. So it is going to have all the data either in string format or in a integer format or in a you can say decimal format. So you have to make sure if all these elements are in a same format, then only you can say this one is array, otherwise it behaves like an list. So this is the only difference between the array and list, and rest are same. So in Python we are going to take the matrix. So matrix is nothing but two-dimensional array you can say. So the dimensional array, one-dimensional, two-dimensional, and multi-dimensional array. So here we are going to use the matrix. So that matrix is nothing but a two-dimensional array. So this we are going to use in the programming. Now let's see the another data structure. So the next data structure is a stack in a Python. So stack means there are two uh, rules of inserting data and removing data from the structures. So those rules are LIFO and FIFO. So what means LIFO? LIFO means last in, first out. It means it is the special type of organizing the elements in a list, or you can say the collection, where the last inserted data is removed first. So here you can see there are few terminology we have to understand here. So let me show you the structure diagram first, then only you can understand. So here you can see, so this is kind of stack. So here you can see whatever element we are going to put on the top of this stack, that is going to be removed first. So here you can see there are three terminologies: top, this is the node, top node, and the push and pop. So when we are adding something in the stack, that is called as push operation. And when we are removing something from stack, that is called as pop operation. So these push and pops both are being done by the top node only. So here we have only one way. At a time we can either push the element or we can pop it from the existing stack. But we cannot perform this operation together. So this is one about the stack. So this is all here we have I have mentioned. So you can see here the elements enter and leave at the same node. That node is called as the top. So further we are going to see the linked list. So there we will see, and queue we will see. So there the place of inserting new element and the place of removing the element are different, so that there you will see the front and back two nodes will work. But here in this stack there is only one node, that is the top node. So from the top node only you can remove or add the new element to the stack. So that is why it is called as the LIFO, means so whatever last time you have added, that only you can remove first. So that is why it is called as the LIFO. So you have to take a note about this stack, follow the rule of LIFO, last in, first out. And this one we have understood. Push is just to add the element, pop is to remove the existing element. And the same way you can see insert remove operation. So what insert and remove operation you can perform from the top node only, from the top node only. What is the use of this data structure, where we can see practically where this is used? So guys, you this is very common use of undo operation. Undo means control Z. Let's suppose there are two things and you just remove those things one by one. So when you will press the control Z, so it will return you the last time whatever you have deleted. So that is what the example of stack you can understand. So this is the very common example. So if you it is basically asked in the interview as well, give the real life example of this stack operation. There you can say like undo operation is kind of stack operation. Now let's look about the next data structure. So the next data structure is queue. So here you can see it follow the different rule. It follow the rule of FIFO, first in, first out. So before going ahead, just see its the structure diagram, how it looks, how its structure works. So here you can see we have one array. So in this array we have this is the front node and this is the back node. So at the time of adding new element, it goes back from backside, and if you want to remove any element, so you can remove it from front side. So here you can see to add the element and to remove the element, we have different place. So insert take place at the back node and remove take place at the front node. And what is the use of this queue? So you can understand it is used for scheduling in the operating system and handling interrupts and so on. Handling said it is used for scheduling the task. It means let's suppose you have scheduled one task at 9 p.m. and another task at 10 p.m. and 11 p.m. So definitely the task which is scheduled first is going to be executed first. That is why it is used in the scheduling. So this is the main approach this structure is following, that is first in first out. It means whatever is scheduled first will get executed first. That is what the first in first out. So other example you can see here, like in the ATM centers and other places, if we are forming a queue, so definitely their first in first out rules are getting followed. So this is all about this queue in the array. Now let's look about the next data structure in Python. So the next data structure is a linked list in Python. You can see here. So linked list is look like similar to the queue, but there is a one difference. What that difference is, in a stack, we have seen there is a limitation. We can add or remove the element only from the top node. This was the limitation of stack. But in case of queue, we got two options. We were removing the element from front node and we were adding the element at back node. But in case of linked list, this is fully free. You can means you can insert or you can delete or you can remove the element from any place. So that is why I have highlighted here, insert and remove can take place from any node. Any place we can insert and we can remove the linked list. So you can see here, so in this all the nodes are linked by each other. That is why it is called as linked list. Let me show you the diagram. Yeah, you can see here all the nodes are connected by each other. So that is why it is called as a linked list. So what each list item contains? So every list item contains two parts. The first part takes its own value, that is called as node value. You can see here every box is divided into two parts. The first part is taking its own value, that is the node value, and the other part is having the address of the next uh, node, you can say. So every element is going to have two parts. The first part is taking its own value, the node value, and the second part is just having the address of the next node in the linked list. So here you can see, so what is the benefit of this linked list? The main benefit of linked list is we can insert or remove from any place of the linked list. We don't need to uh, we don't need to remove or add the element at any specific place. We can remove it from anywhere. So this is the main advantage of the linked list. Due to this behavior, due to this feature, it is very it gives better performance than stack and queue. It is mostly used in the music player. So in the music player, we know very well, like every every parts whatever we are watching are connected by other part. So those are the example of, you can say, the linked list. So this is all about the linked list. Now let's see the another data structure. So the other data structure here you can see hash maps. So this is the most important and useful data structure in Python, and it is mostly asked in the interview if you are preparing for machine learning and other interview. So there you will get the question related to the hash map. So what this hash map? Actually, this hash map is nothing but the replica of dictionary built-in data structure. Then what is the difference between the hash map and the in dictionary? So what it does, let me give you one example here. Like in the dictionary, the value we store in the key value format. Like this we store in the dictionary. Like this. So this is the way of storing the value in dictionary. But in case of hash map, it is stored in a different way. How it stores? Just showing you here. So first of all, it calculates the hash value of this key. So here the key is what? Name. So it calculates the hash value of key. So it hash value of what is the key we have? Name. Then after it stores the value similar to the dictionary. So the value is what? Here Ramesh. So this way. So guys, you can say here. So this one is the way of dictionary what it used, but here you can see in the hash map it is similar to the dictionary. It also uses the key value format, but the difference is only it, instead of taking the key directly, it takes the hash value of key as a key for value. So this is the only difference here I have mentioned. So real life example is like phone books and other applications where we are storing data are the example of hash maps. So let's see another data structure. So other data structure in Python built-in, user-defined data structure you can see here, that is the tree. So tree, as I have already told, like this is a hierarchical structure, means it is not a non-linear, it is not a linear structure. So that is why it is called as non-linear data structure. So this key point you have to make a note. So the tree is what? It is a non-linear data structure, and there are few new terms we can see here: root node and the child and the parent, what these are. So we are going to understand it one by one. So see here. So in this diagram, you can see the first element from where this tree get started is called as the root element. So this is the root node, or you can say this is the first is the this is the root node, and after that every node is having some child, you can see. So the here you can see these are the child element for this particular root. So this is the root node, and these two are the child node, and you can see if the child node is having another child node, you can see here. So this bottom layer, the level number 3, here we have four different nodes, but these nodes are not going to have more child. So if the nodes are not having the child, so these are called as leaf, you can say leaves child, leaves node. So you can see, so root node. So root node is the node from where the tree get starts. So this is the root node, and the parent node means the preceding node is called as the parent node. So from where the other nodes is starting, that place is called as the parent node, and the succeeding node is called as the child node. So here this is the child node, and this is the parent node, and the node at the top, at the bottom, which is not having any child node, is called as the leaves node. So here you can see, the nodes at the last level are called as the leaves, and they do not have any children. So one more point you have to note, like all the nodes, all the nodes having the same level, you can see here, they are called as the sublinks, you can say. So here you can say these are of the level 2, this is the level 1, and this is the level 3. So when someone asks like what is the depth or what is the height of this tree, so you have to say like the number of level. So you can see here this is the first level, this is second level, this is third level. So the depth and height of this tree will be 3, or you can see the number of the leaves is called as the depth or height of the tree. Now see the example like where we use this tree. So basically we use this tree in a HTML when we are creating some web page. So there we just have the HTML tags, and every HTML tag like a div and paragraph tag and UL tag, li tag. So all the tags are having some different child element. So those tree we maintain there in the HTML page. So there are basically there are many type of the tree, but we basically focus in the Python only two type, the binary tree and the heap tree. So binary tree means every parent is going to have maximum number of child is two. Means if one parent is having the child, so that total number of child will be two. That is why it is called as the binary tree. And heap tree means the parents, you can say parent nodes are either strictly greater than or equal to or strictly less than their child. So this is what the heap tree. So we are going to discuss this all in a very descriptive way with a practical example as well. And there we will create one program to understand the working of this uh, in a coming episode, like how we can implement the queue, how we can implement the linked list, how we can implement the tree and graph. This all we are going to understand by Python program. But before that, we have to understand some other things like the function and the object and classes. Then after we can understand those things. That is why I'm not going to cover its implementation in this episode. So for that, I'm going to create separate video, separate episode I will create. Now the last data structure, user defined data structure is graph. So in the graph we have nodes. So nodes we are familiar, and there is a new terminology that is the edges. So what these edges are? So edges are nothing but the you can say the line which is connecting to a different nodes. Here you can see we have the graph diagram. So this is the node, this is the node, but the line which is connecting this and this is called as here as a edge. So these are connecting these two nodes. So edges are nothing but the connecting the nodes. So what is the real life example of this? You can see here. So we basically use the graph to find the list distance between the two places. So this is being used by the Google Map, and the similar way when you run the when you use social media applications, so there you find like a few suggestions are showing in your profile to send the friend request. So those suggestions are coming on the basis of their friends in the social media. So to find the friends or their mutual friends, the algorithm it is used with the concept of graph itself. So with the help of this graph, there are some algorithms. With the help of that algorithm, we can find the shortest distance or nearest node. So these algorithms are there. So we will check its implementation in the coming episode. So there we are going to create a Python program, and we will understand like how these are practically feasible and how we can use this in our program to solve a given problem. So for this episode, this much guys, and in the coming episode, I am going to describe you the functions and recursive functions and the lambda function. So those I am going to describe you in the next episode, episode number 15. Till that time, just practice whatever we have learned here, and just do the practice so that you can get the more confident. If you are new to this channel, so don't forget to subscribe and press the bell icon to get the latest notification. So thank you so much guys.